Welcome back, everybody. Sorry I had to step away from recording for a quick second due to a emergency. We are all good now. Everything's good, so no worries about that. So I'm going to go through what I was just saying before. So yeah, I'll get into more of the details of why it works that way with the 8 and the 10, why it doesn't go there immediately, or the 14, but this is, I'm sorry, the 10 electrons and then the 14, why they don't go in the third row and then fourth rows. I'll get into that later, but then again, this is, right, 10 here, 10 across there, right, and this is 14 down here. So if you go to barium, you hop down to lanthanum, you count out 14, and you hop back up. So, without further ado, let's get back into more of what we were actually talking about here with our S and our P and our D orbitals. You see, each of these orbitals has something called subshells, and these are really the shells of atoms. We have, and there is 2 electrons per subshell. So the S orbital has 1 subshell. The P orbital has 3 subshells. The D orbital has 5 subshells, and the F orbital has 7. Let's spread it out. So, again, we can see here another pattern, right? It's increasing by 2 every time, and it matches our number of electrons. 2 electrons, 6 electrons, 10 electrons, and 14 electrons, since each one holds 2. Each different element, each different layer, overall shell in an atom, right, can have multiple orbitals. Right, the first one, right, you have S, then you have SP, again we have SPD, and then you have SPGF. So our very first layer only has what we call a 1s orbital. It's in the first layer, and it's the first S. After that, we go to our 2s orbital, and then our 2p orbital. Then we go to 3s, and 3p, and so forth. So this 1s here can hold 2 electrons, this 2s can hold 2, this 2p can hold 6 in total due to its 3 subshells. The 3s can hold 2, the 3p can hold 6 in total due to its 3 subshells. This allows us to write a configuration. For example, hydrogen has 1 single electron. So hydrogen has a 1s, 1 configuration. It's the first layer in the s orbital, and there's 1 electron in it. Helium, having 2 electrons, right, as a refresher, hydrogen is up here, helium is up here, they only have access to the 1s orbital. With 2 electrons, it is 1s2. And they literally go in order. After 2s2, we go to after 1s2, we go to 2s1, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6, so on and so forth. Every time you hit a p6 electron, you start again in the next row. So all of these ones end in p6. check my time, just make sure. Okay, so we should be around 27, getting close to 30 minutes. So I wanted to cover a little bit more and actually talk about kind of what these shell models look like first, right? Our first shell, right, again, 2 electrons. Well, actually, let's look at some that are filled out for specific atoms. Right, looking at the Bohr model, you can see hydrogen has 1 electron, helium has 2. Lithium, we put 2 in the first, and then we put the 3rd electron in the 3rd row. You'll remember this from the build an atom thing. It went 2, then 8, then 8, so forth like that. So we have 1, 2, we have 1, 2, 3, 4, 5, 6, 7, 8 that we need to start a new row, and then we have a 1 up here. So, from here, we can set boxes or lines, and we can label them 1s, and the next one we can label 2s. We can label 2p. I might go in a minute when I just finish this up. I might go in a minute when I just finish this up. Okay. If you need help getting her out of the bed, please let me know. I can pause this for just a second. 2p, 3s, right, sorry, put them in it, right, 3s, 3p, 3d, and so on. As we look at our electrons, the number of electrons we have in an element, we can fill out a configuration. To differentiate the 2 electrons, we use an up and a down arrow to show they're different. So we can look at this, we can say hydrogen is 1s1. So it should have 1 electron in the 1s box. Helium, however, is 1s2. It has 2 electrons in the s box. And this is literally just filling in order. Lithium is our 3rd element, so we put an electron there. Right, and then not magnesium. Beryllium is our 4th element. We keep going with boron. And here is actually where we run into a little bit of an oddity. When you have 3 boxes grouped together like this, you add them one at a time. So boron, carbon, nitrogen, oxygen, fluorine, and neon. You keep adding in order like that. So by literally counting out the number of electrons, you can draw these electron configurations with the arrows. These can then all be, translated into, 1s2, 2s2, 2p, 6. That would be the electron configuration of neon. So I have a homework that I would like you to go over. And I want to show you how to do the first one. It's going to be on that website. Wiser, I've been using. This one should work. I apologize for the last one. I realized afterwards there were some issues with it. I had them last year. I thought I'd fixed them. Unfortunately, that is not the case. My worksheets, this is actually a chemistry program that a lot of people use, Pogil. It's a very good one. It uses analogies to explain things. So this is talking about orbitals as if they are rooms in a house. Here we have a 1s orbital, a 2s, a 2p, a 3s, and a 3p orbital. Not getting into the d's in order to avoid overcomplicating things. It gives different definitions of how to kind of look at all of these. So, for example, right, they call these it's saying these are the sunny rooms, right, as they get the sunshine in the morning, and then it's describing these as the pink rooms, probably pink with wallpaper, not getting the sunlight. So, these are, and if you pick up on the subtle, right, S for the s orbitals and P for the p orbitals. I probably should have crossed out everything else. The s rooms and the p rooms. So if a manager were to write a code of who is in and he filled them in this order, right, he could say, I have one person in my 1S room, but it can fit 2. Over here, he has 2 people in his 1S room, his first sunny room, 2 people in his second sunny room, and then 2 people in his pink room, right? The pink room on the second floor, therefore it is 2P. So this pink, right, notice they're adding them one at a time, because why would you take a bunk bed with somebody if there were other open beds? Right, so we go in all the way to this point, right, where it's 1S2, 2S2, 2P6. Again, this code's saying the first floor sunny room has 2 people. The second floor sunny room has 2 people. The second floor pink room has 6 people. The third floor sunny room has 2 people, and the third floor pink room has 3 people. Each of these, right, get a, I suppose it wouldn't be sunny at night, but you can ignore that. Each of these, right, get a, I'm drawing a blank as to what I was going to say. Again, I am spiking a 102 fever, so please forgive me if I do that. From this, you can get a code that identifies, right, what time of day it is in this case, in terms of when he expects to see those full. But for chemistry, you can identify what element it is. And actually, if you look on the periodic table, under electrons, you can actually see the configuration. So if we talk about carbon, we can look at 1s2, 2s2, 2p2. So I would like everybody to stop now. I'm going to end class a little early, and instead I would like you to do some work on that worksheet that should be posted at the start of class. For this, right, for this one we're just kind of looking at it and then answering questions about it. So keep in mind everything I told you about that today in this video, and you come back and rewatch if you need to. You're going to fill in a boarding house based on, right, information given, answer a couple of questions, and go from there. So have a great day, everybody. Best of luck with that. If you need help or any questions on this video, please leave a comment or send me an email. Have a great day and a great week.